Advent of Code 2022 day 12. Hill climbing algorithm. You try to contact the elves using your handheld device, but however, your phone must be too low to get a decent signal. You ask a device for a height map of the surrounding area. Your puzzle input time shows the area from above broken into a grid. The elevation of each square of the grid is given by a single lowercase letter, where A is the lowest elevation, B is the next lowest. A single lowercase letter, A is lowest, B, okay. And so on up to the highest elevation, Z. Let's look at the different position. The location that you should get the best signal in current position has elevation A. The location that you should get elevation Z. During each step, you can move exactly one square up, down, left, or right, to avoid needing to get out your climbing gear. The elevation of the destination square can be the most one higher elevation of your current square, that is, of your current elevation. If your current elevation is M, you could step to elevation N, but not to elevation O. This also means that the elevation of the destination square can be much lower than the elevation of your current square. Okay, this path reaches the goal in 31 steps, the fewest possible. What is the fewest steps required to move from your current position to the location that should get best signal? Okay. So this would be an example of an input. Let's see the actual input. Okay. So I don't know, map should be somehow like, okay, that will be map and starting position, ending position, and then there's parse cell. Then if yeah, raw cell, but it will have like row and column, and then if raw cell equals what is it, S, then starting position equals row column, then return parse cell a row column if it's an E, then it's ending position equals row column. And then otherwise, okay, return unknown jet index of raw cell, and that is the something like, okay, Python list of these letters. Okay, string dot ASCII lowercase. So then I can just go like for row index and row in enumerate file data dot split by new line. For column ID and that'll be enumerate row. This will be parse cell row ID and column ID. So I can print map and starting position, print ending position. Okay. And then what is the field steps required to move from your current position to the location that you should get the best signal? Okay, so Python is there like a built-in okay, no, not built in. So I don't know, just copy paste the Python BFS. Okay. There's the graph. Visited queue. BFS. Okay, visited graph 5. So I suppose actually here instead, this would be the coordinates. So this could be like ending position, visited. Oh wait, visited. What? Visited graph node. Then that was 5. Wait, 5. If neighbor while queue. yeah, so I just want to this will be starting position, and then it will also need like an ending position. Well, so end, so basically if what end equals if, no, I don't like this because, okay, what is the Fiesta script moves? I don't like this Python BFS. No, I mean it's fine. It's just that, okay, we need like parents equals like an empty dictionary, and then basically for neighbor not visited will be like parents neighbor equals m, and then if m is end, then just return, I guess. And now just the only thing is that we need to build the graph based on the map. So basically either work directly on the map, which means that, okay, here visited append node. So this will be like map, and then q append node. Yes, this will be map. But it will be map m0 m1. No, this will be like get neighbors. Okay, get neighbors okay, map and m. And then it will be like get neighbors map m, so row column that will be m. And then the possible movements are down, right, left, up. So, okay, possible movements. Will be like no, -1, 0, plus 1, 0, 0, minus 1, and 0, plus 1. And then for, I don't know, delta row, delta column in possible movements. Okay, so next not equals row minus 0, but row plus 0, and column plus d column, and then if next coordinate not in map, so it's like if it's like on an edge, well, it's like a non-existent coordinate, basically, like next to an edge or something, then continue. And then okay, what's the, yeah, the map has the numbers. Okay, so here I can just put like the rule, because okay, you can, the destination square must at most one higher, can be much lower. Okay, so basically if map next coordinate is greater than map n plus 1, then also continue. Otherwise, return next coordinate. No return. Yield. It's empty. Why? So what's okay, print you visited here, visited an end. Okay, you is a print end. Oh, what is that? But anyways, it's not getting the neighbors. Yeah, it's not getting any neighbors, which must be wrong. So let's see. Print next coordinate. It's never yielding any of them. Why? Oh wait, oh, it's not in map. Okay. That was wrong. So it's not in. Oh, okay, so next coordinate. Next coordinate 0 is not in range length map, or next coordinate 1 is not in range length map 0. And this is map M0, M1. And also next coordinate 0, next coordinate 1. So now, okay, basically, okay, number, okay, sure, length, shortest path equals 0, and then parent equals ending position, while parent, but really just while true, if parent in parents length of shortest path is increased by 1, parent equals parent, else break. And then print length of shortest path of 31. Yes, that's the correct answer for at least the example thing. So now let's see with the real data. It's a lot more of searching. 520. That's the right answer. As you walk up the hill, you suspect that the elves will want to turn this into a hiking trail. The beginning isn't very scenic though. Perhaps you can find a better starting point. To maximize the exercise while hiking, the trail should start as low as possible. Elevation A. The goal is still the square marked E. However, the trail should still be direct, taking the few steps to reach its goal. Any square at elevation A to the square. So you'll need to find the shortest path from any square at elevation A to the square marked E. There are 6 yeah, 6 choices. What is the few steps required to move starting from any square with elevation A to the location that should get the best signal? Basically, this is just turning the whole thing around. So basically now we're searching for the end. So starting from start and searching for an end, but then instead of that we can start from end and search for anything that has the lowest possible elevation, which is like 0, I think. You can't see it though. Well, remove all of these prints maybe. Yeah, there are these zeros. So basically, I can just say, okay, here in the ending position, well, this should be the ending position. So that's the starting position actually. And then here we don't have end. Here is just like, okay, if map M0 M1 equals 0, then return. so now the only problem will be that... Oh no, we return, okay. Final node is M. So maybe we start final node as none or whatever. And then here, parent will be final node. Tuple index out of range, why? Oh wait, global node. Then also tuple index is out of range. Oh, what? That's not M, it's map. Shortest path is 5. That's better path, which is 28 steps. So that's wrong. But really, this should be like the shortest path to any... Oh, okay. Now the rules have also reversed. Because now here, it should be M and next coordinate, next coordinate. Yeah, now it's 29. So I can just put this one back. And it should be, okay, 508. That's the right answer.